In this problem, I need to find f of g of x and g of f of x, and I need to determine whether the pair of functions f and g are inverses of each other. We're given that f of x equals 8 divided by x minus 9, and g of x equals 8 divided by x plus 9. So the first thing I need to do is find f of g of x. Well, we always work from the inside out, so the first thing I have to do is replace g of x with its definition. So I'm going to get f at, instead of g of x, I'm going to write its definition of 8 divided by x plus 9. So now, to find f of 8 divided by x plus 9, I go to the definition of f of x, and wherever you see an x, you're going to replace it with 8 divided by x plus 9. So I'm going to get 8 divided by, instead of x, I'm going to have this whole expression, 8 divided by x plus 9. And then don't forget, I also need a minus 9 in the denominator. So I'm going to get 8 divided by, in my denominator, 9 minus 9 is 0, so I'm just going to get 8 divided by x. So I need to divide a whole number by a fraction. So you turn the numerator, the whole number, into a fraction by dividing it by 1. So I get 8 over 1 divided by 8 over x. And then how do you divide fractions? You take the fraction in the numerator, leave it alone. So I get 8 divided by 1. And then you're going to multiply by the reciprocal of the denominator. That just means flip this fraction upside down. So I'm going to get x divided by 8. Now, since I'm multiplying, I can reduce these two 8's, and I get 1 times x is x, divided by 1 times 1 is 1, and x divided by 1 is x. So we've found f of g of x, and it just equals x. Next, we need to find g of f of x. We're going to do it the same way, working from the inside out. So I'm going to get g at, instead of f of x, replace it with its definition of 8 divided by x minus 9. Now, to figure out g at this expression, you go to the definition of g, and wherever you see an x, you're going to replace it with 8 divided by x minus 9. So I'm going to get 8 divided by, instead of x, I'm going to have this expression of 8 divided by x minus 9, and then plus 9. I need to simplify this first term. Since I have a whole number divided by a fraction, I'm going to make my numerator a fraction, so I'm going to have 8 over 1 divided by my fraction in the denominator of 8 divided by x minus 9, and then don't forget your plus 9. Now, dividing fractions, you take the fraction in the numerator, leave it alone, so I have 8 over 1 times the reciprocal of the fraction in the denominator. What's the reciprocal of 8 divided by x minus 9? It's x minus 9 divided by 8, and then plus 9. Since these are multiplied, I can reduce the two 8's. I get 1 times x minus 9, which is x minus 9, over 1 times 1 is 1, so x minus 9 divided by 1 is just x minus 9 plus 9. Since negative 9 plus 9 equals 0, all I get left with is plain old x. So g at f of x equals x. Lastly, we need to determine whether the pair of functions f and g are inverses of each other. And how do we do that? Remember, to show that f and g are inverses of each other, we must show that f of g of x equals x and g of f of x equals x. Well, we found f of g of x and it equaled x. So we got part 1. Did we get part 2? Yes, g of f of x also equaled x. Therefore, we know that f and g are inverses of each other.